right, at this time, if you would, for the last time, go ahead and clear your desks, except for 2 clean sheets of paper and a pencil. 2 clean sheets of paper and a pencil, which is what I've said for all the other quizzes, by the way. 2 clean sheets of paper and a pencil. One of the sheets of paper is for a cover sheet. The other sheet of paper, at the top, it's first and last name, and today's date, which is 4/23/21. 4/23/21. And this is Powers Quiz 4. Which again, technically is not that bad. I think I mentioned in the past we've gone as much as 7 or 8 quizzes some years. Didn't need to go that far this year, which is good. Powers Quiz 4. And we're down 1 through 16. This is going to be a mixture, Gavin. We're going to do some powers and some roots. It's just going to kind of be a hodgepodge here. All right, number 1. What is the cube root of 343? What is the cube root of 343? Number 2, what is 16 squared? What is 16 squared? Number 3, what is 2 to the 4th? 2 to the 4th. Number 4, what's the square root of 289? What is the square root of 289? Number 5, what is 8 cubed? 8 cubed. Number 6, what is 2 to the 6th? 2 to the 6th power. Number 7, what's the cube root of 125? The cube root of 125. Number 8, what's the square root of 400? The square root of 400. Number 9, what is 18 squared? 18 squared. Number 10, what is 9 cubed? 9 cubed. Number 11, what's the square root of 169? What is the square root of 169? Number 12, what is the cube root of 216? The cube root of 216. Number 13, what is 4 cubed? 4 cubed. Number 14, what is 2 to the 5th? 2 to the 5th. Number 15, what is the cube root of 8? The cube root of 8. And number 16, what is 15 squared? What is 15 squared? All right, let me go and collect those from you. If you would, go and take out your textbooks. Turn to page 281. Page 281. And you had 2 through 20, the evens, for me last night for homework. Page 281, numbers 2 through 20, the even. It was sort of fun picking on you guys without you being in the room. So I was recording Wednesday night. Imagine the sorts of stupid things you might say, Maddie. I don't pick on you very often. I had to work something in there. All right, page 281, numbers 2 through 20, the even. I trust between the Abeka video you watched and then yesterday's lesson, you feel like you've got the hang of this now? Yes? Sort of? No. No, it's just sad. Okay. Well, let's take a look at this here, Brecken. Now, number 2. There is no way we could possibly screw this up. So, Brecken, let me call on you. What is the square root of 36?
2 times
Brecken, what's the square root of 36?
square root of 36 of 6.
6.
Square.
Square root of 36 is just 6. Plain old, ordinary, rational 6. Number 4 for redemption, Brecken. Can you take the square root of 45? No, you can't do it because it's irrational, right? But we can factor the square root of 45, Brecken. What rational factor is in 45?
9
Times?
3
9 times 3 gives 45?
5
9 times 5, there we go, yeah. All right, now Brecken, you said this was the rational one, right? This is irrational. This is rational. What's the square root of 9? 3. And since you can't take the square root of 5, we just write?
square root of 5.
And there's our answer. Did you have that?
No.
Does it make sense now? All right. Let's take a look at the next one. Number 6. We have the square root of 27. Noah? Can you take the square root of 27? No, 25, yes, 27, no. Which means this is a little bit bigger than 5, right? Square root of 25 is 5. Square root of 27 is going to be like 5.2, 5.3, something like that. So no, that means we need to factor it. How could we factor a 27? 9 times 3. Now, which of these is the rational factor? The 9. So we take the square root of the 9 then.
3.
And since 3 is the irrational factor, we just have to write
3 to the square root of 3.
3 times. It's being multiplied. It's up against it. 3 times the square root of 3. Is this what you had for your answer on number 6?
No, I had 9.
Okay, does it make sense now? Were you working along with the video as I was talking? Were you sitting there like a bump on a log? Ooh. All right, Maddie. Number 8. The cube root of 40. Now, all those square roots we've been thinking, 4, 9, 16, 25, 36, 49, 81, all those, they don't matter now because it's cube root. So, Maddie, how did you factor 40? Good. Not 4 times 10. For a square root of 40, 4 times 10 is great. For a cube root of 40, 4 doesn't do you any good. It's got to be the 8 times 5, where obviously which of these is the rational? The 8, and the cube root of 8 is 2. But since you can't take the cube root of 5, there we go. So there's my answer. 2 times the cube root of 5. Is that what you had for number 8? Good. Let's take a look at number 10. We have the square root of 175. And Brecken, it's a big number. Big numbers can be scary, can't they, Brecken? Yeah. And so sometimes with big numbers, we try like dividing it in half, or dividing it in thirds, or dividing it not in fourths. Remember, 4 is already rational. Maybe by 5 or 6 or 7 or something like that. Or, that's one method for big numbers. Or maybe we can clearly see a square root of 4, a square root of 9, a square root of 16, a square root of 25, a square root of 36, a square root of 49, etc. Thoughts on either method here, Brecken? Yeah, I actually think the 25 kind of pops off the page. Despite this being a larger number, the fact that it ends in 7, 5, to me makes it easy to spot that 25 very quickly. So we could factor the 175 into 25 times 7. 7 quarters makes a $1.75, where I'll take the square root of one of the numbers. Which number? 25 to get 5. We take what we can, right? But we leave what we can't. 5 times the square root of 7. Is this what you had for number 12?
I had 5 squared times the square root of 7.
Gotcha. Does it make sense now? Because technically this is the square root of 5 squared, but the square root of 5 squared is just 5. Again, that's why I like my method better than the Smith method. All right. Though, did any of you feel like her method actually worked easier for you? No? Okay. All right. That was number 10. Number 12. Square root of 432. Now, Noah, this is massively scary. I do see a 9. Like 4 plus 3 plus 2 is 9. So I see that 9 would go in, but we're going to be here all day if we do it that way. So here's where I'm thinking maybe divide it by 2 or by 3 or by 5 or by 6 or by 7 maybe. I don't know. How did you factor 432?
I don't really understand how to do this.
Don't understand how to do it. All right.
Well, I do now, but
Now you do. Okay, well, let's go ahead and do it now then. Let's try just cutting it in half and see what happens. Noah, cut that number in half for us and let's see what we get. 2 goes into 4.
2 times.
Now left over 2 goes into 3.
16.
Yeah, 216. Is 216 a square?
Yeah.
No, it's cube. That's why we have to know our list really well, right? Now, if this were a cube root, man, I'm in business, but that doesn't work. Okay, can I divide this by 3? Yeah, sum of the digits adds up to 9, which is divisible by 3. Let's try dividing by 3. 3 goes into 4.
4 times.
Is that a square?
Yes.
Ah, there we go. So apparently we want to factor this 144 times 3. Okay? And you just try, if that hadn't worked, I would have tried, well, I know 5 doesn't go in, right? But that would have been my next number, maybe a 6 from there. But yeah, 144 times 3, where we take the square root of 144. Ideally, we'd like to take the square root of all of it, class, right? Like that would be like ideal world. Like we see something like on number 2, the square root of 36, you're like, oh, I can take the square root of the whole thing, this is great. At least that's what we should be thinking when we see the square root of 36. But we can't take the square root of all of it. So we just take what we can get, right? Here we get 12, and of course, 12 times the square root of 3. And there would be our answer. Anyone get this for number 12? Nobody got that. Okay. Did anyone try dividing it by 9 and getting 9 times, what is that, 48? 9 times 48, anyone? Oh, nobody. No. How did you factor it, Maddie? Okay. Brecken?
That's the exact same thing I did.
All right, number 14, we have the square root of 80. Maddie? Good, 16 times 5. Now 4 and 20 would work, but then you have to factor the 20 into a 4 and 5, so our answer comes to 4 times the square root of 5. Number 16, we have, oh, this is great, 3 times the square root of 16. Now, when there's already a coefficient out here, remember, I said ignore it. Just focus on the radical. So all I'm worried about is the square root of 16. And